Okay, so I'm going to do a video for all the questions that you did in the homework yesterday. All the ones that I didn't do. Oops. All right, so I think these with practice should be pretty easy. Basically all you're doing is changing CKs to X's. And then, so for number 2, we'll do integral. The interval determines the limits. And then this determines the integrand. So that'll be like x squared minus 3x. And then this delta x really is dx. All right. And then number 3, same idea. Okay, go from 1 to 4. Always the smaller one on the bottom. For now, at least when you're talking about area. This will be 1 over x dx. Okay. And that's it. Okay, these next ones are just using that kind of formula. Whoops. So here, I'll put the formula here. A to b of c dx. So c is some constant, just like all these functions, all these integrals. C times b minus a. Okay, for 8. So it's c times b minus a. Okay, 9. C times b minus a. C times b minus a. Okay, so wait, make sure, yeah. Okay, so that's it for those. Okay, so these will start needing graphs for. Oh, let me get a graph. Whoops. Okay, let me get a graph the other way. All right. So let's do 14. Okay, use a graph of the integrand and areas to evaluate the integral. Okay, so 14. We only care about this function. This function inside, this called the integrand. The function that's inside the integral, we only care about it from this x value to this x value. So what I'm going to do, I'm going to plug in each, the upper and the lower limit and the upper limit. I'm going to plug it into this function just to get points, and then from there I think it'll be easier. I won't do that every time, but at least with linear functions I'll do that. Okay, so if you plug a half into there, so maybe we'll go by halves. So here, okay, so we'll make that a half. Okay, that does not show up. All right. We'll call that a half. What am I doing? Call that a half. And then this will be 3/2 here. All right, so we just plug those in. Plug in a half, you get -1 plus 4, which is 3. 3. And then plug in 3/2, and you get -3 plus 4, which is 1. Okay. And then we see this is the area that we're looking for. Okay. All right, so this is just a trapezoid. This is 1, this is 3. The height, this height is 1. Okay, so for 14, to get the area, it's 1/2 b1 plus b2 times height, and that's just 2. Yeah, okay. Okay, let's do, whoops, let's do 15, 16. Okay, so that's a semicircle, radius 4, centered at the origin. But we only care about it from 0 to -4. So you can see if you plug in 0, you get 4, which makes sense. That's that point. Whoops. 0, 4, that's that point. Plug in -4, you get 0 here. And then we can see this is just a semicircle here. And so we're looking for this area. Okay. Alright, and then for that we'll just use pi r squared and then divide by 4. So this is 1/4 pi, radius is 4 squared, and that's just 4 pi. Okay. Oops. Okay, so next one is 17. Alright, so that's an absolute value, and we only care from -2 to 1. Okay. 2 to 1, so this will look like this. And then, oops. Okay, so we have kind of these two areas that we're finding. And so we'll just find each one separately and then add them all up. Add them both up. Okay. Alright. You know, this is 2 and this is 2, this is 1 and this is 1. I mean, we could do 1/2 base times height for each of them. So 1/2 base times height plus 1/2 base times height. And that's it. Yeah, so this is just 2 plus 1/2. so that's 2.5. Okay, next one. Okay, so 18. Okay. All right, so at least like this part, to graph it, this is like negative absolute value of x, so that'll be like facing down, absolute value of x facing down, and then this will shift it up 1. And we only care from -1 to 1. So we have this and just this. And you can see when you plug in -1 or 1, you get 0. And so this is it. Alright, so this is a triangle. So we'll do 1/2. So the base is 2 and the height is 1. Base times height is 1. And that's it. Okay, next one, use areas to evaluate the integral. So we'll do the same thing, but and I think these were the problems that people made the most mistake on. Oh, actually I just need one of these. Yeah, this is the problems that people made the most mistakes on. So your answer, you just have to be careful what's in terms of b. Like a lot of times the base and the height are in terms of b. And I'll show what people did, what a lot of people did. Okay, so we want to go from 0 to something, right? So we can at least plug in 0 into the function to see that 0, 0 is a point on the function. And b is some positive number. We don't know, you can stop anywhere, but so like let's say this is 4x, so we know it'll have a slope of 4, and you have to stop somewhere, I'm just gonna draw the line, I guess. And then at some point, doesn't matter where, I'm gonna make it real like arbitrary. At some point, it's like this point here that we'll call x. Sorry, that we'll call b. Okay, and that is some x value, right? Okay, and so we want to find the area from 0 to b. So we still want to find this area just like those other problems. In general, I mean, like conceptually, this is the exact same thing as the previous problems. But I know it's a little weirder. Okay, so this distance here, whatever this distance here, that's b. And then what's this distance here? That's the thing that I think people made the most mistakes on. Do you get that? Depends on what b is. That height is whatever you get when you plug b into the function here. So that height is 4b. Right? So a lot of people kind of maybe put b here and then drew a line up like this, and then they said the height was 8. So a lot of people called this b but said the height was 8. But the height's not 8. The height changes depending on what b is. It's not some fixed height. And so that's it. And so now we can get the area here of this triangle. 1/2 base times height. That's 2b squared. Okay, and it makes sense that a lot of these are going to be like have a squared term because this is area. If to get area you square distance, b is representative of distances. So it makes sense that you'd square some distance to get area. And so you'd have a b squared somewhere. That won't always happen, but that'll happen a lot. Okay, another one of these. Express the desired quantity as a definite integral and evaluate the integral using theorem 2. Okay, first we'll express it as a definite integral. Okay, so find the output from a pump producing 25 gallons per minute during the first hour of its operation. Okay, so first hour would be like from 0 to 1 maybe, but the fact that this is in minutes, we need units to match. So when they say the first hour, we can kind of interpret that as the first 60 minutes. Put that as 60. Okay, and then the rate is a constant rate. It's a constant 25. And then we'll just have a dx there. Okay, just so you know, when we're integrating with word problems, this function is almost always a rate. And it'll make more sense once we kind of get into this more. It'll make more sense why this kind of has to be a rate. It doesn't have to be, but why it's a rate most of the time. All right, and then we have that theorem that just says it's the constant times b minus a. Which is that 1500, and this is gallons. Okay, and so we did this the calculus way, but we could have done this some kind of more algebra way, and that's what we ended up doing rate times time, and that's like work done. Okay, so this next one, write the accumulator function a of x as a polynomial in x. Okay, accumulator function has a constant down below typically, and the variable is in the upper limit. Variable could be in the lower limit, but conceptually for most word problems that usually wouldn't make sense. So usually the lower limit is some constant and the upper limit's a variable. Okay, and then notice that this variable in the integral is t and this is x. You'll always want these to be different, and you'll want whatever your functions in terms of, like here the area functions in terms of x, so you want the limit to be in terms of x, and then this can be kind of anything, doesn't matter. And again, we'll figure out why, or we'll see why later. Okay, so 34. Okay, so it's going to be pretty similar to those questions with b that had the b's in it. So we'll find, write the accumulator function as a polynomial. The fact that this only goes from 0 to 3 is kind of irrelevant for what we're about to do. So we want to find, you know, this, so let's say it goes from 0, from 0, and then the function is 0 at 0. You know, if you plug 0 into 3t, you get 0, so that's a point. And then we're going to x equals 3, that's the farthest we go. And x is 3, 1, 2, 3, 4, 5, 6. Okay, so we have this triangle. Okay, but we're not going to 3 necessarily. We're going to x. So like, let's say x, we'll just put it right here. That's 3, that's 0, and x could go anywhere on this between 0 and 3. Okay, so then x, for the x that I chose, just that random spot, we're really calculating this area. Okay. And then kind of just like before with the b's, which will end up being a function of x. This distance is x, this distance is 3x here, and so it's 1/2 base times height. That's what that would be. Okay, so that's the polynomial that represents the area depending on whatever x you choose. Okay, so these next ones are just calculator questions. 39 and 40, you'd have to kind of set up the problem, but 37 and 38, they basically just give it to you. Okay, so for 37, first thing, just hit the math key, and it'll take you to this math screen, and then just hit 9 because you really want this f in it. So hit 9, it'll take you to the next screen, and then you just fill in however the integral is, just fill in everything exactly like it's written. So hit math, and so hit 9 to get to this, and then just fill in everything. And you get the answer. That's it. Okay, so that's 37. So here I'm going to do the rest in the calculator to at least just give answers. Actually, let me do 38. Okay. Whoops. Damn it. All right, so those are the rest of the answers there. You can pause it and check if you want. Okay, for number 42, I decided to at least graph it in the calculator just to, I don't know why, but just for practice. So this is like, that blunk when I took the picture, that should be at 2 there. Alright, and so I just graphed that function, and this is the window I used, and this is the graph we got. Okay, so the idea is and I think what these problems wanted you to see is it doesn't matter if there's discontinuity. So just whatever the function is, just focus on a certain piece maybe. So we'll focus on this piece. So all you do is draw lines to the x-axis here, and then you find the area of that rectangle, and you'll do the same thing with the next one. Find the area of that rectangle. And so just all these rectangles you're finding area of. Okay, all the ones that are below the x-axis will be considered negative area, and that one above the x-axis will be considered positive area. Okay, so we just kind of find the area of each one. This was negative 18, and really whatever these intervals are 1, so really you just do the y value times 1, and so really just the y values of each of these intervals is really also the area. This is really just negative 18. The next one is negative 16, negative 14, 12, 10, 8, 6, 4, 2, yeah. Negative 12, negative 10, negative 8, 6, negative 4, negative 2, and that's positive 2. Alright, and so we just add up all these. All the negatives, we could kind of do stuff to make it go quicker. So you could do like the first and last is 20, and then the second here is negative 20. These are negative 20, these are negative 20. So you have 4 negative 20s, and then a negative 10, that's negative 90. 6 to 5. 2 equals negative 90 plus that little 2. That's negative 88. All right, and that's it. And they just wanted you to see. I think the main thing is that discontinuity doesn't matter. You're just finding all this area for all these. And you know, they also just wanted you to see that area below the x-axis is negative, and so it'll cancel out with any area that's above the x-axis. Okay, and then just getting all that area. Alright, so that's it for this. I'm going to do also, so this is all the homework previous night that you can check, and that'll maybe help on today's homework. Also, there's a couple different problems I put at the end of today's homework, and I'm going to do a video doing 1 or 2 of those, and I'll post that soon.